you're shipping fast and you're shipping frequently, you need SLOs to know if you're actually meeting people's experience and making sure you're shipping a quality product. If you keep shipping and shipping and shipping and it's not meeting people's needs, you're building the wrong thing. And this is where I think reliability is the most important feature of a product, and it's the one that's hidden in most product systems. It's a feature that's there that people expect and it's innate. I want to use your thing, it's there for me to use, and it should operate how I expect. If it's not there, it's kind of a non-starter. It's like you're dead in the water.
So if you care about quality, you care about SLOs.
Yeah, if you care about what people think about your software or how your system performs, you care about SLOs.
Welcome to Alexa's Input AI. Today we're tackling a question that every tech leader is grappling with. In a world reshaped by generative AI, do the old rules related to keeping our services reliable still apply? To help us answer that, we've got the perfect guest. Sal Furino is a customer reliability engineer at Bloomberg, where he operates on the front lines of high availability systems in the fast-paced finance industry. He's also a respected voice in the site reliability engineer or SRE community, where he's known for his ability to translate incredibly complex technical concepts into actionable real-world strategy. Sal, welcome to the show.
Alexa, it's a pleasure to be here. Thank you. And also thank you for that lovely intro. Can I just copy and paste that and throw that in my eval? That would just be great.
Yeah, sure. Why not? You're my first Bloomberg guest, actually.
Really? Wow. That's surprising. There's so many smart, talented people here. I'm honored to be on Alexa's Input.
Yeah, there are a few that I also want to have on, so we'll see what happens with that. But for now, you're my first, and let's get into it. So why do you think that it is that the better a system is designed, the less anyone tends to notice the people that are behind it?
That's a great question. If I had to think about it, I think it's just well-designed systems kind of have people removed from them. You don't see a face or something in there. It's just something that's hidden and done for you in the background already. And I think that's why when people notice it, they notice the system is working well. Sometimes humans aren't involved. And it's when people aren't so much involved, they just kind of think it's there and it's expected. And it's just like the machine's kind of doing it all for us. It's automated or automagic, even though there is a lot of people behind in order to make that machine operate and work effectively.
Exactly. I think this is where a lot of platform, infra, SRE, engineer types come in. When it's done really well, you don't realize how much you need them until something breaks, for example.
Or even just how much is done for you already. How many times have you used a platform that's just oh, this all just works and it's great, instead of me having to just string together all that stuff together in order to make it happen? It's wonderful when that happens, and it provides such a great customer experience to people. And it's something that people might expect in using their software nowadays, that the bar is just getting raised higher and higher.
How did you become a customer reliability engineer at Bloomberg?
Yeah, so my story there is I spoke at SRECon, and a bunch of people at Bloomberg were attending, and they really liked my talk. And then a month later, I was walking into Bloomberg on my first day. I enjoy speaking and talking about reliability. I've always gone to tech talks and things. I love learning. I've always considered myself a lifelong learner, and it's something that I've always enjoyed doing. And in terms of the actual speaking part of it and being a customer reliability engineer instead of a site reliability engineer, I've always been I always known I wasn't the strongest technical person. I never, on any team I was on, I was never the best programmer. I understand system design pretty well. I could run projects reasonably well. I had some good soft people skills and things. And I just kind of fit there. I was better at teaching other people reliability than I was actually, doing some advanced system design work or coding an algorithm in order to reduce storage capacity or something like that. That's never was my strengths. And given my background in mathematics, I kind of naturally gravitated towards telemetry and observability. And that's just kind of where I started made a niche for myself, so to speak, there in the industry and what I wanted to do. And it wasn't until I stopped trying to be the best programmer on the team and started just leaning into my strengths that I got to have a lot of career success.
Yeah, I love that you mentioned leaning into your strengths. And I didn't realize that math and reliability, telemetry, that does kind of go together.
It really does. And that's where I felt I kind of just found the perfect niche for myself in being a CRE. And I'm really happy that Bloomberg values that.
Yeah. So you mentioned your title is customer reliability engineer. Can you walk me through what does that exactly mean and how that customer focus in your title affects your day to day?
So the customer reliability engineer role was originally started by, I think, the cloud providers, most notably at Google. And it was essentially a bunch of people to teach other external Google cloud customers how to use the cloud, essentially. And by proxy with that, there was a lot of people focusing on reliability with the cloud as well. Not just can we get it over there, but how can we make it work and work reliably? And that's kind of where that job title kind of came from. And how I explain it is I'm an SRE that talks more than I push commits. Do I still push commits occasionally? Yes, but that's not a primary focus of my job. It's more on the adoption and people to understand and change their culture in a way to do something a little bit differently. And that's kind of a lot more where my strengths lie.
And how does that compare to an SRE?
So I think SREs generally are responding to pages. They are dealing with issues in production. They're mitigating active incidents, and that's generally more of their focus. I generally focus on a lot of things preventative before we even get into production. How can we get people to think and operate a system that exists today and do something different? I think SREs have a lot more hands-on to actually implementation. A lot of what I do is a lot more theory, design, education, and getting people interested in wanting to do the thing.
Talk to me a little bit more about the systems that you are observing. Obviously, Bloomberg is in the finance sector, big in financial markets. How does that affect your job?
A lot of our customers and users of Bloomberg systems and software have high expectations on how well it has to perform. And we do our best to try to meet those expectations. And this is where we invest heavily into observability so we could better track and measure those expectations and try to create an experience that our users want to consistently come back to.
How do the requirements of the Bloomberg software systems compare to maybe something like a social media?
I'm sure people are very happy using Bloomberg software and systems, but I wouldn't consider us like a dopamine app or anything like that. It's not like a social media app in which people, if it's not responsive, people can just easily go off to another social media app and do something different. At Bloomberg, we provide a very concrete services and offerings to our customers that bring financial data to the world. There's I think very few companies that operate at a scale and precision that Bloomberg does.
Yeah. And from your perspective, is reliability more of a technical or a cultural one?
It's both. You need the culture, and if you have the great culture and know the good tech, if you have good tech but they don't have the culture around it, you're just going to burn people out. You need both. They go hand in hand, and this is why a lot of people, sometimes they call it flack and calling it a social technical system, but it really is. It's not just a system and alone. It's how people react, think about it, interact with it that really matters, and that's where the social aspect of it comes in together. It's also like our collective understanding of how the system is operating or performing, or how well it should operate or perform. It's really both. You can't just have all of one or the other.
And how do you go about getting people to be proactive instead of reactive when it comes to reliability?
Yeah, so there's tons of different approaches there. And I think the best way is to have a bake-off. What are you doing today? And then how can these things be a little different? And I try to pick one or two people that are interested, and I build them up and try to show them that this could be a better way of measuring your reliability, essentially using service level objectives or different ways to think about different signals to better measure customer user expectations along software that you're responsible for. These are all different things in which I try to generally coach and build up people to think a little bit different and to maybe try something new. Hey, maybe they hated it at first, but then it turns out they like it. Maybe we got a little green eggs and ham kind of scenario here. I think I'm allowed to say green eggs and ham. I think that's in public domain by now. I think that's fine. But if not, it could just be, just something that people just gradually get exposed to. Sometimes doing something new for the first time isn't easy, and that's okay. And that's why people like me exist to help guide people on that journey.
Yeah, and there are certain things that to engineers building applications or systems that aren't as fun as the building part. That's probably things like handling security and reliability. So I'm sure you
Don't
encounter.
forget documentation. Like that, like I know with like AI, like documentation's gotten like a lot easier for engineering teams and so forth. But like I feel it's like that. It's like the principal thing, and not the principle. It's a thing that engineers always kind of begrudgingly like. I don't want to write the docs for this thing. I just want to go off and build it. And I feel like naturally with engineers, where like engineers are naturally people who want to build things and make things easier for other people. And I think it's important for engineers to understand the context in which they go off and build something. So like, let's say you're an engineer for like a town or something, and there's like, oh, we have to cross this river, but that's across the town. I'm just like, okay, what do I have to do as an engineer? Do I need to build you? Do I need to make a ferry service? Do I have to give you a manual on how to build a boat out of a tree? Do I have to like build a bridge here? And what does this bridge need to carry, or what you need to carry and go across this? This is where you need to build solutions that fit what people need, and you need to know how they want to interact with the thing you're building. You can't just build something in a silo without understanding the context in which you're building it for and how people want to actually use it. Otherwise, you're probably going to build the wrong thing there.
Yeah, that makes sense. And when you're talking to people and getting them to get on board with this whole reliability initiative, you've mentioned at times you feel a bit like a couples therapist. What is
Yeah.
the most common argument that you've had to mediate?
It's not really mediate. It's kind of just more of different people have different formed opinions, especially if they've been working with systems for a long period of time. And sometimes they're a little bit of, they need a little bit more convincing to understand the value in a new approach or a new method to do something. And a lot of times when I see people where they have entrenched opinions, I try to understand how they got there. Like from first principles, what made you feel this way and in what way? Tell me the war stories. Tell me what had happened there. And then I try to introduce, well, hey, why don't we just try to measure this thing? Because you don't want to get paged at 3 a.m., right? Like, wouldn't you rather know of an issue sooner if a service is degrading and so forth, so we could better respond to it, or maybe try to do some things automatically if we like trust the signal instead of sometimes getting alarms for things that really aren't that meaningful? How can we help you? How can I help you develop a more high quality signal? And this is when it's becoming, and this is where generally when I partner with product and engineering together, that you really kind of start doing that. Product representing the end user, the customer, and saying what they want or what they're trying to achieve in using our software, and engineers trying to hook it up to the actual bits to measure those different proxies for expectations around the software system. I think a good antidote there will be engineers, they spend a lot of time building these systems, and they want to sometimes measure like how fast the cog in the machine is operating, or in less industrial terms but more on software engineering terms, they want to measure how well this microservice or some parts of infrastructure, like maybe a message queue or something, is operating that they're responsible for. And they don't think about what's the overarching thing which is outputting, and are we making the customers happy in using that, who actually use that thing. And by the way, I'm going to use customers, users interchangeably. People, generally when I say that, there's some expectation around a software system, and how well are we doing in terms of managing that expectation or meeting it?
Yeah, so are you holding up Grafana dashboards, different burn down charts, and saying, what do you see here? How does this make you feel?
Sometimes sometimes it is like looking at different dashboards and different metrics and saying how do these different signals interact with each other. Let's say you're looking at a couple different SLOs. You have one on latency and another on measuring like the HTTP status codes of a service. Well, there's some relationships between those things. If latency is low and you're not getting a high amount of errors, it's probably good. We're fine. But if latency is low and we're getting a high amount of errors, then wait, something's wrong, and we're not maybe unavailable, or we're not meeting the customer's needs there. And latency is still low because it's sometimes faster to serve up a 500 or some 500s than it is to actually deliver a successful response. Versus if latency is high and you also have high errors, it's something is backlogged and we're starting to time out or have some other issue there. Like there's something really wrong with the system. Likewise, why if latency is high and errors are low, hey, maybe we have a more burgeoning issue, something we're starting to hit some type of bottleneck or saturation point here, and we're not yet at the point yet where we're starting to get timeouts or other requests or starting to fail over onto other parts. Maybe our caching is keeping up for us, but latency is still high for some reason, and let's investigate it. And this is where evaluating all those different signals is important and knowing what they each mean. And that's when I talk about having a high value signal, it's a signal in which teams actually are involved and think about and manage and spent time creating. And it's not just a rule that was either applied for them or it's super generic to any software system. It's something specific to the use case in the delivery of the software.
Yeah, those nuances are really important. For example, I can think of two nuances that I've dealt with for like returning 400 when the end result really shouldn't have been a 400. It was okay that the logs weren't found because the service wasn't running anymore and we were trying to pull the logs. So like knowing your error codes and returning the right errors make a big difference as well. Also, like one time I was counting retries and it would be successful, but we were getting a lot of like maybe we get 2 failures and then the third one would be the retry would be successful. And knowing how to monitor those also matters too, because if you're recording every failure, regardless, then you might get pinged for a lot of things that were successful. So I think knowing the nuances of your service is extremely important.
Yeah, and that's like a lot of what the work I do puts in place. A lot of the systems we build are super complex. There's so many different interaction points, so many things that can and will go wrong at some point in time. And how we think about, respond, and create better signals to better measure that, we get a better idea of how well people are actually experiencing the software we all create. And that's something I feel as engineers we really should be a part of and measure.
Yeah, so with that, let's get into what SLOs and SLIs are. Can you define them for me?
Sure. So SLIs are signals or measurements. You could think of them as maybe like with how prevalent observability and telemetry are. They're generally some type of metric that's generated by some type of query, either to logs or based upon metrics or even from a trace, whatever. It's some value. SLI is service level indicator, and those are our signals. SLOs are service level objectives. So this is where we take that indicator, we then apply some additional things to it. First, we say what is the objective? What's the value in which this objective needs to meet? Then we have a target, which is how often do we have to meet that objective? So this is generally represented by some level of nines, 90%, 95%, 99, 99.9. We call this in industry 2, 2.5, 3, 4, 5 nines, etc. for how often we need to meet that target. Then you have a fourth thing, which is a time window, which is how long does the target need to meet its objective? So over what scale of time do we need to assure we are meeting this objective here? So these could be something from an hour, a day, 7 days, a week, a month, a quarter. These are different time values in which we're measuring us and holding ourselves accountable to meeting this objective over this period of time. And then if you put all those together, you kind of get a secret fifth thing called an error budget. And this is something in which you could generally express your reliability or unreliability of a service in the form of a sentence. So let's say you could express an error example for an error budget would be, you could say 0.5% of any requests received by the service can take longer than 500 milliseconds over any 1 week period. So that would be equivalent to having an SLO measuring a latency with an objective of 500 milliseconds over a time window of rolling 7-day window. And this and the target value for that would be 99.5 for that. So like this is where you put it all together, and you could say how much allowed errors or amounts of unreliability in which the service can tolerate. And it's not really just the service can tolerate; it's the user's expectation of it. So you're essentially saying 0.5% or 0.5, I forget what target I put in. There's some amount of allowed failures in which we're allowed not to meet that 500 milliseconds objective. And for the purpose of this, like singular SLO, we don't say how much it didn't meet the objective or not. We just say it just didn't meet it. So this is how much of a not stellar experience can we provide. And once you have the idea of an error budget, you could start saying, this is the allowed amount of unreliability in which we're allowed to have, in which the user base can tolerate. So how can we best use this budgeted amount? How can we best know how much of that we've already expended so it can inform how fast we need to respond or to do something there with it? And this is where sometimes I recommend people to have several SLOs, pretty much the same SLO, but maybe set a couple tiering objectives. In which you adjust the objective and also the target value. So maybe you have like one objective saying 99.9% of the time, I need to be less than 500 milliseconds, and say this is our good SLO. And once this starts burning, okay, we're using some of our good error budget. But then maybe you have another one that's higher. Maybe you say 99% of the time, we have to be less than or equal to 1 second. And once we start burning this error budget and this starts getting into issues, then this is like a more severe issue. Like this is how much worse the system is degraded. Like it's nearly double the latency here. Again, these examples are purely for educational purposes, but this is where having that tiered approach can help people understand how bad is the service getting for people who are experiencing it in different levels of service in which we're trying to instill.
So tell me more about the core philosophy.
Wait, hold on. I forgot about one. I forgot about SLA. So SLAs are kind of more, SLAs, first of all, they're not for engineers. They're for lawyers. Their SLAs are generally service level agreements. There are things that are meant to be in contracts. And these are values that are stated to ensure certain overall larger levels of service, and is the service generally functioning. They also are, since they're lawyers, they love penalties, lawyers. So if you don't meet these obligations, you don't meet the terms of this agreement, what actually happens with that? So this is where you might get service credits, you might get maybe some money back, maybe there is regulatory penalties, who knows? Like this is where like SLAs are kind of more for lawyers and other bodies like that. They should be informed and used to better give maybe engineering and product direction on how well they need to meet certain things. If you think about it, like this is what our baseline agreement is, but the whole idea of an SLO is that you've already burnt through your error budget several times over, like at least once, if not several times over already, before you're even in danger of breaching your SLA. So these are kind of, we're higher SLOs generally try to hold yourselves to a higher level than you do with the actual agreement in the contract.
So what types of services need SLOs?
So I think lots of services need SLOs, but then other services, you could kind of get away with not having them. And I think the biggest differentiator there for me is volume. How many data points is this service that you're looking at providing, and what time windows are you looking at that for? So it's so every telemetry system has different goals and how many data points in which they can aggregate up to, and different polling windows and so forth. And like this is where I try to get people to say at least you're allowed to have one failure based upon the target and what you're putting in place. So what's a good example here? So let's say let's say you have a time window for an hour. What's the amount? And let's say we aggregate it up. Let's keep the math easy. You're able to have a data point on your telemetry system 15 seconds, every 15 seconds. So that would be 4 times 60. So that's like 240 different time intervals over the course of an hour, right? Is that right?
Sure.
4 times 60. Yeah. So based upon that, how many allowed occurrences can we have in that based on the volume of service that can inform that SLO? How many allowed failures are we allowed to have there, and how can we aggregate that up? If your service only has like 5 requests over an hour to it, you don't need an SLO for that. You could get away with traditional monitoring. Even if you have it 100 over that hour, you can get away with that. I would try to encourage people to have higher levels of volume of service, and that's where SLOs really shine. At the end of the day, they're really based on statistics. Everyone, I think, for middle school and high school statistics, the more data points you have, the value of N, as that grows, the more stronger, more confident you are in the results of that. So that's where I kind of encourage people. There are some services that don't need an SLO for volume from telemetry purposes, but I think all services and all things generally have an SLO. You're just maybe not measuring it. So let's forget about software for a second, and let's talk about maybe eating at a restaurant. If I go out to a restaurant and I want to get something for lunch, if I ask for a cup of soup for lunch, that should come out a lot faster than if I ask for a well-done steak or something. They're not boiling the water for your specific soup. That's already there and ready for you. All you have to do is maybe ladle it out, throw it in a cup, and then serve it to you. Maybe they add a little judge or something onto it. But they're not over there grilling a steak or something for me to eat. You have different inbuilt expectations on how long it's going to take for you to get served or to get the thing you want. And I think and people have done this, which is like, oh, it's been a really long time. And maybe you look around the restaurant and it's empty and it's like, why is it taking so long to get for my soup to come out? Like, why is it taking 15 minutes? Like, it's dead here. But if you see it's like really busy and people are going here, there, and everywhere, maybe 15 minutes is reasonable in that different scenario here. So this is where I think all services, all things that we have in our day-to-day life have these inbuilt SLOs that we're noticing that, hey, something's different or off from what I expect. So truthfully, everything has an SLO. It's just whether or not we actually measure it effectively. And maybe let's take a different example here. Maybe I think everyone has this one person in their friend group that's always late to everything, no matter what. So if that person all of a sudden started showing up on time, you'd be like, oh, what changed? What happened? Versus if they're still consistently late, it's just kind of that's the expectation for them. Yeah. So like it's all about like the expectations and what you actually think or what your experience is previously, and it's going to inform what you think is going to happen in the future.
I want to talk a bit about how people or how we come up with these numbers to measure. Maybe first, can you talk to me about what 99.9 means? What does it mean when people say 2 3 nines or 4 nines? And what's the difference in the type of service that needs 95.9 versus 99.9?
Yeah, so I think the more nines you add, the more durable the system needs to be, the more stable it needs to be as well. The more you need to invest in maybe duplicating transactions or being able to parallelize stuff so that you ensure that if one fails, you're still able to deliver on it. The more redundancies you need as well. Like it's the more you shoot for nines, the more reliable in which you need to be, the more you need to invest in making sure that your people are meeting you're meeting the expectations of people. And when you don't, you need to have ways to fail over smartly and correctly in order to still ensure that level of service. Something like a lot of times I have to sometimes coach people to the idea of trying to achieve 100% reliability or uptime or something like that is really difficult and hard. These are systems that are generally very constrained. You generally don't change them very often. They're ran several times over in processing. Like this is really important for safety critical infrastructure or software or things that are created or services there. So think of maybe things in healthcare or transportation, like on a plane or something like that. Like there are certain levels of reliability in which people expect and needs to run and ensure it's operating correctly most of the time. And when it's not, you still have that manual in which you can fall back to in order to try to self-correct the system there. So those different levels of nines are kind of different levels of complexity or different levels of expectation in which how reliable the service needs to be. And I kind of want to go back to that example we were talking about before about engineers and building something to get people across the river of a town from one town to another. You need to understand the situation in which you're in and the level of service which you need to provide, and so you can better design the system to operate that effectively. So you're not overbuilding something, you're not underbuilding it either. You're trying to find that Goldilocks, so to speak.
I like that you point out that you don't need to overbuild it. Some services don't need 3 to 4 nines. But can you talk to me a bit about what services do need 3 to 4 nines generally? And what is the difference between needing 3 nines or 4?
So some systems, I think, like you get away with maybe even just 1 9. So like maybe it's like your cafeteria's lunch menu. That's fine just being a PDF on a server under someone's desk. But then there's some examples of systems like maybe, I don't know, a market trading application or something like that people have a lot firmer expectations of how performative that is and needs to be. And this is where you need to really understand your customers' expectations in order to scale that effectively in order to meet their goals and expectations.
Maybe like
in terms of
cloud providers, they probably have a few nines.
Cloud providers do. They do have a few nines, and like I would probably say like telemetry systems as well. It's, hey, is the system working? Can I pick up my phone and get a dial tone? I guess that's not really so much a thing anymore with like mobile phones, but like it's just kind of there. You assume it's there. I guess it could be more akin to, hey, am I able to have connectivity on my phone or something like that to actually
like
get data?
Right? I'm sure that was a huge problem for them because it feels like they probably have a few nines as well.
Situations like that can be very challenging for organizations, and it also a certain reputational damage as well. Like there's some issues in which are hard to recover from. as well. And this is where you need to measure that effectively in order to better understand when we're starting to have a bigger issue before it becomes more widespread. And this is why a lot of software companies make investments into observability and telemetry and spend time really understanding these systems which you provide and understanding customer user experience.
So do you know the difference between how 3 nines and 4 nines, how many hours or how much time downtime you're allowed in a year?
But there's a chart for that. I could do a Google. All right, 3 nines is you're allowed to have 8.7 hours of downtime per year. For 4 nines, you're allowed 52 minutes of downtime per year.
Strict.
That's not a lot of time. And 5 nines, you're allowed 5.2 minutes of downtime throughout a year.
I wonder what services have 5 nines.
It really depends. So again, these are probably services you think about and use, but you don't think about because they're just there and always there and transparent, like your phone service, like data, except maybe when you're on the subway or something, then it's going to cut out.
Like I personally haven't built a service that requires 5 nines.
Yeah. I've helped teams measure that. And this is where maybe there's maybe a good example here for software is that there's some systems in which need more than 5 nines. And it's not so much the time there, but it's more so transactions and occurrences. So if you think about like maybe data durability, if I go off to read something, if I go out, I should be able to write something to storage and then I should be able to read it. And the data in which I read, it should be what I wrote to it. And this is maybe where you want to check against other replicas. Hey, is what we have stored matching what we have in other places to make sure we actually wrote the right thing and are able to call upon that? And that's like a data durability SLO. And that can easily have, I think for cloud providers, it's like 10 nines or something there. And it's measured not by time, but the bits read and wrote. So this is like, how many bit flips are you allowed over like a terabyte or of writes, essentially? So like it's kind of measuring like at that level. And this is where it's really important to understand the different levels in which you can apply these signals, not just upon time, but upon occurrences of what actually is the thing that's happening in a given scenario.
Signals generally that people want to use. Like I know latency is also one. You mentioned that one.
So there's like generally 4 golden signals out there. And I kind of think of these as more so units of measurement. So first is availability, and this is generally measured by status codes, knowing is that what we've given correct or not correct, essentially. Correct in the terms of were we able to serve up that request? Someone asked us for something, were we able to give them some reply? Then there's latency, which is duration, how long did it take to do something? Pretty simple, and it's something that everyone kind of knows. Next is data correctness. Did you give me the right thing for what I asked for? So this could be, I went and have an order on an e-commerce website. Did you give me my order or did you give me Alexa's order here for what we ordered for a certain thing that was processed? And then lastly is saturation. And this is kind of more of an infrastructure type metric of knowing the bottlenecks of your service and knowing where is the longest amount of time in order to complete it. Maybe it's on disk I/O, or maybe it's on a message queue, or maybe it's on a certain part in your infrastructure in which you need to scale that's heavily CPU bound or GPU bound or something. Knowing what is the point in which we need to scale up or scale down the service effectively when we're experiencing a high level of load, or when the system is under functioning. This is the part of the service that is most critical, and if it starts operating at a degraded level, it's going to affect the overall experience or metrics there as well. Those are their 4 main signals, and this is where I kind of think of them as general units to the proxies of customers' expectations. So if we maybe let's go back to a restaurant example. Maybe is the restaurant open? Is equivalent to like an availability metric, or after I sit down at the table, is there a server there who could actually take my order? Likewise as well, how long did it take for them to take my order or to give me my food once I placed the order? Data correctness would be, did I get the right thing? Did I got a burger, is this medium rare or well done? Or did I ask for the salad not to have walnuts on it? Did it still come with that? And then lastly, saturation point might be things that are more important in measuring, like in the back of the kitchen. How long did it take for me to actually put together that salad and chopping up the tomatoes or the prep and mixing it all together? And my backlog says a bunch of other stuff on the grill already, and I can't put that burger on there. Or maybe my servers are backlogged and I can't take people's order right now. Like what is the saturation point or the rate limiting step of the transaction in the given time? And this is where sometimes maybe you don't want to measure one thing but several.
It sounds very much like a chemistry equation. What is the rate limiting step?
Yeah, that's exactly how I phrase it to folks, to get them to understand what are the different steps of this reaction or of us completing this process in order to synthesize the correct response that we're looking for, or synthesize the good experience in which people are expecting of our service.
That's a great talk idea for the SLOs, a chemistry themed talk.
Maybe we should give that talk together sometime, Alexa. Well, like, what can SREs learn from chemists or something? But yeah. I don't know. I'm not a chemist. I think we both have, a comp chem background a little bit.
Yeah.
So, what can SREs learn from comp chemists? Or, I don't know, maybe we should pair up with somebody else on this who's maybe more on the sciencey side of things.
Well, I did do organic chemistry, and a little bit for a year. I was in the lab, but I don't think we should use that experience because I don't think I did very well. So.
All right. We'll figure it out.
So with that, let's go ahead and start talking about SLOs in the age of GenAI. From what you've seen, how do SLOs change with these new types of services?
They change a little, but I think their first principles are still the same. We still want to measure things. We just applying them to different use cases that are, the units are still the same. We're just applying them to different use cases that are important given this new additional context. So maybe it's availability of the system. Am I generally able to submit a prompt? Am I generally able to accept a prompt and give a response? How long does it take me to give a response to this? And then is the response kind of correct? That's a bit harder to measure. Maybe you see repeated prompts or something. And then saturation is how many active prompts can we support processing right now based upon our current GPU load or network bandwidth or some other thing in order to actually go off and do something. So this is where maybe there's different actions that are taken based upon different parts of a GenAI system and so forth. And there's probably different things you want to measure as well, not just the latency of our prompts, but maybe between prompts. Maybe you want to start measuring inference or something there, and maybe making sure that the different services in order that deliver that response are operating effectively. So this is where it really varies a bit, but I think you still can create SLOs for GenAI systems.
How does GenAI systems being non-deterministic, how does that affect measuring and reliability in SLOs?
Yeah, so I think this is where, and you're saying non-deterministic in terms of the prompts, the responses to prompts, and it's not so much the not deterministic in the, hey, we don't know if we're going to actually get a reply here or something, but it's the quality of the reply in which you're talking to here. And this is where maybe you have to rely upon your users. Maybe you have to do some additional training, if they're not actually responding correctly to certain prompts, or adjust that as needed, or maybe divide it up into different context windows and so forth. How can you start shifting and understanding your signals and which users are giving you and adjust your infrastructure accordingly? Very rudimentary would be, if you notice you're getting a bunch of prompts over and over again, hijack a response and saying, hey, are we actually meeting this for you or not? Tell me ask me how we're doing. I think there was a famous New York City mayor, Ed Koch, used to go off and ask people, hey, how am I doing? Type of deal. And I think maybe that's an approach to take as well.
Yeah, it definitely seems like there are different ways to understand how well your system is responding and how well it's performing. But broadly speaking, how have you seen the mainstream explosion of GenAI change this conversation around system reliability?
I think it's kind of shifted a bit. Are there sometimes availability issues? Yeah, but I think there's a lot more focus on latency and data correctness. Is the response we're giving to a prompt appropriate and actually answering someone's question and answering it reasonably well? And this is where you need to that's something you need to actually kind of unravel and try to measure and come up with proxies for measuring that.
That makes sense. So we're still measuring latency. Maybe we just have different metrics around it, and we're still measuring correctness, but there's just a little bit more trickiness in the values we need to measure that.
Correct. And especially since it's not deterministic, maybe you have a lower target there. Maybe it's we're instead of it shooting for several levels of 9s, maybe 1 is just fine. maybe 90% of the time is perfectly fine for data correctness for this. And it's not really data correctness, but maybe like prompt correctness or something like that in which you're measuring.
So for GenAI systems, we're still going to have error budgets. Typically, those are built on pretty predictable outcomes with a typical REST service, for example. How does this change, if at all, with GenAI?
I don't think it changes at all. Like, you still have an error budget, you still have to respond to them, you still have different triggers in which you go off and respond to it. Like, the process of creating an SLO is agnostic kind of what the signal is. You have a time series, which is pretty much a value and a timestamp. The implicit meaning on what you actually do and respond to it is all based upon what the signal is and how you understand that system to give you insight of your system and its health and its performance. So I don't think it's different there. You have to do anything different in that regard for GenAI.
It seems like a lot of the foundations are still there. I actually wanted to ask you a bit about error budget too. How are we supposed to react when we spend our error budget, and what does that mean? What are the next steps there?
And this is where you need to understand how the different triggers for your error budgets. So the error budgets, let's just review real quick, is the allowed amount of failures you're allowed to have over a certain time window. So when you need to measure how much of those are consumed, so this is generally % error budget remaining. There's also how fast are we experiencing these issues right here and right now. This is the error budget burn rate. There's also time to exhaust, which combines how much we have left, how fast we're burning through it, to have like a linear extrapolation based upon time. If we continue burning this rate, how much time do we have until our error budget's gone? There's also some other signals such as like sustained error budget burn rates and stuff that look into what's the rate of change of the error budget. So essentially the burn rate of the burn rate, to kind of give you those inflection points of how quickly you're going up or down. But those are kind of more advanced. I try to keep it for people initially to some more of the basic initial understanding of these things, to know how many failures how many failures or occurrences of unreliability which we've had, and how can we better manage going forward. So I think a good example of this would be for your % error budget remaining. You might look at this before you push a release, before you make a change. Hey, how much error budget do we have left? Do we have enough error budget so that if we might have an issue, we have enough time to respond and take care of it? If you notice that you have 80% of your error budget remaining, hey, maybe you won't think twice about it. Because maybe sometimes when you have a change, historically, you've only maybe burnt 20% of your error budget or whatever. But if you had maybe 30 or 40%, you're just maybe might give you pause. Before we do this release, maybe we want to take some extra precautions, or maybe we want to push back the release until a later time. But I think what's kind of generally more popular is people to maybe doubling on-call that week, setting up additional telemetry, scaling out the system proactively before we make that change, or some other things. Maybe you get more customer support representatives on standby, or notify people that you're making this change and they could be impacted. There's different things you could do in that scenario. And this is where SLOs start having that conversation. So that was the % error budget remaining. So let's say we actually ship this release down. We made a decision to ship the release, but the error budget burn rate will let you know how much error budget is actually happening right now. If you have an error budget burn rate greater than 1, that means based upon what the current rate of the burn right now, error budget will be exhausted by the end of the time window. So it's generally, if an error budget burn rate is greater than 1, you're in some issue, you're in some hot water. If you get to several multiples of that, so that if you're at 2, 3, 4x burn rate, and you have a sustained for a period of time, this means you're having 2, 3, 4 amount of failures than you should for this period of time. So this is where you need to be proactive and hey, we ship this release and our error budget burn rate is 5x, 6x, or something like that. We did something wrong, and now it's leading to a bad experience for our customers, and it's actively affecting them right here, right now. And maybe it's something transient. Maybe it just spiked for a little bit, and then it went down. That's okay. That's fine. We don't have to alert on that. But if it's at a certain point and sustained to a certain level, this is something that really is warranting of my attention, and I should go off and give that attention. This isn't just a page I can ignore. And then lastly, the time to exhaust is combining that. How much time, what actions have to take in order to try to mitigate this? How much time do I have to do it? So if I go off and see I have 10 minutes to my error budget is exhausted, maybe I might try a couple different things before maybe I roll back that release. But if I see I have 3 minutes left of it. No, I got to roll that thing back now in order to preserve the amount of error budget I have left.
When is it okay to consciously go bankrupt with your error budget, if it ever is?
You're really not supposed to. And when you do, this is where you really should take a look at what's happening. And this is maybe you're in a disaster scenario. And this is where your error budgets are kind of like, oh, we've already burnt through them. You want to look at them to let you know when you're starting to recover. And when have we actually stopped the bleeding? When has it actually been mitigated? And this is it's also useful as well if you haven't burnt through it all, you still look at your burn rates. Have they dropped down to like 0.5, 0.1, 0.2, whatever, like normal levels and what you're expecting for that service? You know that you're back to regular levels of service. However, if you already burnt through your error budget like once or twice or 2 or 3 times over, this is when you're really starting to be endangered, and this is where you really need to like bring in other people. Probably even before that, like bringing other people. Like on call is meant not to be a hero and save the world, but it's triage. When you're in that like real disaster or real issue, you need to bring other people involved. You have to get more folks involved in trying to help restore and mitigate the service impact that's happening. So again, SLOs and error budgets are a guide for conversations. Like let's say you burnt through all your error budget, like maybe once or twice over, and you didn't get a single customer complain about it. Maybe your SLO is too strict. Maybe you need to relax it. But if you went and had a big error budget burn and people were complaining, you know you actually got it right, and you need to take more actions to actually fix the issues itself. Because you know the SLO is giving me that good high quality signal that there was an issue, there was a problem.
That's a good point in knowing when and how you should change your error budget, like making it larger or making it smaller.
That's actually something that like a lot of engineers struggle with, adjusting their targets, adjusting their objectives, and trying to dial it in and try to find the right scenario that's matching the customer user's expectations. And this sometimes takes time with teams. They have to kind of iterate on it there, or create several and try to pick the one that fits best in measuring it during the quiet time. Like in the SRE book, they generally recommend folks to have hard and fixed objectives that are set by product or set by user experience and not by this level state of the system. But sometimes that's hard for people to quantify, especially like for product. Like, can a user really tell the difference between a 300 and a 100 millisecond response time for something that's happening? That could be difficult. But yet there's huge engineering challenges in order to deliver those. If it's another system that's taking in those requests, then yeah, it tells the difference, and it's huge and it's very impactful. But so this is where it really varies. And I think this is why with SLOs, you need to know when you need to follow some rules and what are the scenarios in which you can kind of bend them a bit in certain areas.
Can you talk to me a little bit about the difference of a system that failed a lot in a short amount of time and failed the same amount over a long period of time? What are the differences in the system, and what does that mean?
Well, they're completely different outages. Like if you have one 100-second outage, that's vastly different than 100 1-second outages. And they're going to indicate different issues that are happening in the system. They're going to be responding differently. Like that one larger outage is kind of more disruptive. Like there was a clear change and it was affected. Something happened and there was a single point of failure to kind of restore it or something. Or maybe not a single point of failure. There's always multiple contributing factors. There's probably like a new change that was pushed or something that was triggered around a certain time in order to just get that, to generate that signal and was sustained for a period of time. Or a whole bunch of things coming together to create that scenario for that failure. But if you have 100 1-second outages, this is a lot of transient things. So it might be more of looking into the actual requests that are happening that to cause these failures at this period of time that cause these periods of instability. So like I think there's going to be different tools for investigation. There's different things going to happen, and it's different ways to mitigate it. So like it also depends on your user base. If your user base is actually trying to use your system at that time, you have that 100-second outage, and a bunch of people trying to use it, that's going to be a lot more impactful to your reputation and how people perceive the reliability of that software than if you have 100 1-second outages. It's just like, oh, wait, it didn't happen, but I was able to retry and then it worked for me. Oh, okay, I could go on. They could go on in life. It's a little bit more forgiving. So they are completely different outages, and it's kind of hard to compare the two. They each need to be investigated for different things because they're both going to consume the same amount of occurrences on your error budget.
And so is this one way that you can look at an SLO dashboard, for example, and tell the difference between a bad incident and a bad system?
Correct. That's exactly what you would use Everbudget just to try to figure out and trying to help you diagnose that issue.
So how do you sell the value of investing your time and resources into creating these robust SLO frameworks to a leadership team that's maybe focused on shipping new features yesterday, like all orgs are? What is your elevator pitch to the people who are making the decisions about this?
You're shipping fast and you're shipping frequently. You need SLOs to know if you're actually meeting people's experience, to making sure you're shipping a quality product. If you keep shipping and shipping and shipping and it's not meeting people's needs, you're building the wrong thing, or how people expect it to function. And this is where I think reliability is the most important feature of a product, and it's the one that's hidden in most product systems. It's a feature that's there that people expect and it's innate. I want to use your thing. It's there for me to use and it should operate how I expect. If it's not there, it's kind of a non-starter. It's like you're dead in the water.
So if you care about quality, you care about SLOs.
Yeah, if you care about what people think about your software or how your system performs, you care about SLOs. So the S in SLO stands for service, and software generally provides a service for people and makes people's lives easier. But that also is applied to other places throughout our whole lives and our experiences in which we experience service. This could be like, I don't know, I keep saying restaurants, maybe I'm just hungry right now, but this also is important for like public transportation, or when you interact with somebody, there's a certain level of service in which you expect, and you have some innate expectations on how well that's going to operate and function. A big benefit with software is that we're able to measure it, and we're able to measure it quickly and adapt quickly to it as well. It's not as if we're like, I don't know, something that takes a long amount of time, or for some reason I want to say construction. That's a different level of service than it takes in order to build a project or to do a renovation or something. If someone says it should take, a month and it ends up taking 3, you're going to be a bit upset. And that's not what the expectations were originally set to.
Yeah, and I think a lot of times people underestimate how much that user experience and that service that you're speaking of actually matters, especially for products, the ease to use, how quick it is, how just intuitive it is. All of those things really matter. So being able to measure the response and the usability that you're getting from your product is important.
Yeah.
Cool. Well, this has been incredibly insightful. Where can our listeners go follow your work, learn more about engineering and what you're doing, and check out all the cool things happening at Bloomberg?
Yeah, well, I'm on LinkedIn. You could find me, and I'm also on most socials as @Sfurino. You could find me there. But if you want to know what's happening at Bloomberg, I highly recommend you checking out Tech at Bloomberg. And we could put some links out there for folks in the description of this video to check out and see what myself and all the other smart and talented engineers at Bloomberg are up to.
I'll ask you one final thought. If you could get every engineering team in the world to stop making one common mistake when they first adopt SLOs, what would it be?
If I could get engineers to think about something differently and do one thing different on their SLO adoption, it would be to think about the happiness of your users and try to come up with proxies to measure that. And don't just jump to measuring only the health of your technical system.
Great. Well, thank you for coming on.
Thank you for having me, Alexa.
Thank you so much for listening to Alexa's Input AI. And if you want to follow along with my new episodes, writing, content, everything I'm building, you can find me at alexagriffith.com, on Substack, on YouTube, or wherever you listen to podcasts. If you enjoyed this conversation, it would mean a lot if you subscribed, shared this episode with a friend, left a quick rating or a comment to help more people to discover the show and keep these conversations going. Again, I'm really grateful you're here. This podcast started as a side project for me a few years ago, and every listener who reaches out or keeps coming back reminds me exactly why I love doing this, and I love putting so much time into it. I hope this episode gave you something to think about, something to talk about. So always stay curious, stay grounded, and I hope to see you next time. Thank you for your support.